Hello, 6th grade students. This is Mr. Bornheimer. Today we are going to kind of unwrap or look at or kind of start to really unfold this idea of motion. Okay, so the very first thing we're going to do today is we are going to start to talk about motion in terms of, how do you really describe how something is moving? We say speed up or slow down, but if we stop and ask ourselves, what is speeding up? Well, so something's getting faster. Okay, well, what does that mean? That's not always the easiest thing to describe. And so we're going to go ahead and unpack that today. Okay, so I wanted you to label this in your journals. I want you to label this motion notes. Okay, and this is going to go with our brand new lesson 2. And we're going to be talking in this lesson 2 is kind of unpacking this idea of forces and velocity and acceleration and all those things. So we're going to kind of plug that in right here. And just so you know, you should have already done like a title page, and I would have liked it if you had written down the objectives from the purple book. I know for a fact that I told Mrs. Rush's class that, but I'm pretty positive that Mrs. Palmer's class I did not tell that to. So if you open up the purple book, there's the focus question, there's the objectives, and so you should have already created a title page for lesson 2. You should have written down the objectives, and you should have written about your focus question. And if you haven't done those things, you have time to get those things accomplished, but definitely want to be focused on that. So let's go ahead and get started here today. So the first thing we have to understand is we've got to define a few things. And the first thing we got to define is the space in which we're working with. When we measure motion, okay, so when we measure motion, especially at the middle school level, it's important to understand that this has to happen in a flat space / environment. Okay, so case in point, okay, if I was looking at a car going by, so I'm going to draw this car, okay, so if I was looking at this car going by, and it was zooming by, and it was traveling away from me ever so slightly, the car itself would still look like it's moving, but every little while it would look a little smaller. And you know that when objects travel away from you, they look a little smaller. When they travel towards you, they get a little bit bigger, right? And so this car might start to look more and more like it's moving away from me. And you can kind of see that here, right? It kind of looks like that it's curving off in the distance. And this might mean that it's going to go off into the horizon, all right, like so. And so when objects get smaller, they are moving away from us. And so when we measure motion, it has to be kind of in the same flat space environment. We call this the same plane that we are, which means that if I was standing here, okay, and I was measuring the distance to this first car, all right, and let's say that it was 100 feet, then that car has to stay 100 feet from me to the best of my ability as I'm measuring how it moves. So a case in point was I was standing here, okay, and if here's the ground, and here is a wall, okay, and here's that brick wall, and I dropped a ball from that wall, and it was moving downward, like so. Okay, so this is kind of what we did outside. For the most part, the distance between myself and where that ball is moving up and down is staying the same. That is good. That helps us to really look at an object and how it's moving to get the right picture. Okay, to get the right picture. So let's go ahead and take this idea of motion and let's grow it a little bit. Let's run with it. All right. So let's say that I have an object. Let's say that object is let's say that object is, I'm trying to come up with something creative here. We'll come up with something. Let's just say that I have a box. And that box has some wheels. So I'm going to go ahead and draw those. Okay, I'm going to fill those in. Okay, that box is going to be traveling, and so it starts, okay, so we're going to say it starts here, and it travels, let's say, to here, so we're going to call that the next stop. Here's the thing that's really tricky about this, is when I'm measuring objects, I have to make sure that I'm measuring the same part of those objects each time. Okay, so if I were to, I'm going to move this little box just a little bit here. If the first time around I was to measure to the back tire, and then on the next time around I was to measure to the front tire, okay, that creates a distance of about that far. But if I were to measure from the back tire to the back tire, that creates a distance traveled of about that far. And the problem that you're going to see happening is that those distances are different, which means that how we measure an object, where we start our measurement, makes a huge difference. If I am going to measure a car traveling down the street and I look at the front tire and how far it moves, I have to focus on that front tire the whole time. So in this particular case with this car, we're going to focus on the front wheel here, and we're going to focus on the front wheel here, and we're going to focus on that front wheel. So if this is the start position, then these two objects travel from point A to point B, and that is an accurate distance. All right. So we could say, all right, that we can now, once we know how to measure objects and how they move, we can look at really how they're moving. So I'm going to go ahead and paste a couple of these cars. So there's one. There's one. Okay, and there's one there. All right, and so again, we're going to measure the front tire of each of them. I'm going to do that actually right here. Okay, and if we take a look at these dots, there's a couple things that we have to understand, and this comes back to like the video analysis we did in class, in that, let's say that I took a photograph, okay, so I take a little photograph of this box at the first position, and then I take another photograph, of the object as soon as it gets to the second position. And then I take another photograph as soon as that box gets to the third position. And then I take another photograph when it gets to the fourth position. Okay, so we can, and each time I take a photograph, I'm taking it every second. So this photograph would have been taken at 0 seconds. It was the very first photograph. 1 second later, I took this picture. The 2 seconds later, I took this picture. And at the third second, I took that picture. Okay? And if it helps so that it's not getting too confusing, and you can keep it if you've already drawn it, but I might just switch these over to like A, B, C, and D. So we're not getting confused by numbers. So if I look at this example, right, if I look at these cars, and I look at how they're moving, I see that the car starts at A. 1 second later, it's at position B. But then I notice that at the 2 second mark, the distance between the dots, let's go with purple here. The distance between these two dots is not the same as the distance between those two dots. And if I look at that 3rd second mark, where the cart's at position D, I notice that the distance between those dots is even further. This tells me that if the cart traveled 1 meter here in a second, and it traveled 2 meters in that second, and it traveled 4 meters, and I'm kind of making these numbers up to make my point. In that second, this would have been 1 meter per second. This would have been 2 meters per second. This would have been 4 meters per second. These are speeds, okay? So this right here is a speed. This right here is a speed. This right here is a speed. And what we see happening is that the speed is not, I repeat, it is not the same for each part of the motion of the block with wheels. So this tells us that this object is getting not only faster, but it's also increasing the distance traveled each time. Okay, so we see an increase. We see an increase in the position or spacing of points, which tells us that we see also an increase in the velocity. Another fancy word, or another word for the fancy word velocity, is speed. Okay, so we see an increase in the velocity or speed of this object. Okay, so to kind of recap here real quick, we're talking about motion, we're talking about how things move, we're talking about how that ultimately the objects have to be the same distance away from us, to the best of our ability. They can be off a little bit. We started to talk about this idea of motion, and we talked about these objects that are moving from point A to point B to point C to point D, and how that the position or the distance between those particles is increasing. Okay, so if the time interval is 1 second, okay, so it's to go from 0 seconds to 1 second is 1 second, okay, and I know, and I kind of guessed at that this object traveled 1 meter, then I know that they traveled that 1 meter in 1 second. And if they traveled 2 meters in a 1 second interval, then that's 2 meters per second. And if they traveled 4 meters, okay, in 1 second, then that would be 4 meters every second. So this idea of motion is really crucial here, and talking through these different pieces and talking through these different parts, it is important to understand. So I'm going to you to take a moment in your journal right now, and you're going to do some guesswork here. And I'm not going to give you any pictures, but I'm going to draw a couple of examples, and I want you to guess at what these examples might be asking of you. Okay, so let's say that I have an object that's moving. Okay, and the first time around, that object looks something like this. Okay, so right now on your paper for this number 1, I want you to kind of hypothesize. Is the object speeding up? Is it slowing down? Okay, so is it speeding up? Is it slowing down? Or is it staying the same? Okay, remember those dots represent a point on an object. So it could be these tires and this cart. All right, but basically those points represent positions on an actual object. And so the question is like, what is that object doing? Is it speeding up? Is it slowing down? Or is it staying the same? Let's try number 2 now. Okay, we have an object. These are actually, these types of drawings actually have a name. It's kind of crazy in science. We kind of name everything, but they do actually have a name. These are called dot models. Okay, so the question for number 2 is, are they speeding up, slowing down, or staying the same? And you can feel free to circle something if you wanted to. You could circle any of your answers. Okay, so I'm going to go ahead and copy this phrase. Okay, I'm going to do this one more time here, and I'm going to look at one more kind of example here. It's going to look something like this. I want you to explain what's happening in number 3 as well. All right, let's go ahead and take a quick break, and you guys finish up this work, and we'll come right back to it.